Hey all, Dan here, Periodic Audio. Gonna finish off a little more measurement stuff like that. I'm gonna show you something I should have gotten to yesterday, and then one other measurement system we have here. I'm out in the warehouse, as you can see. Yeah, we're Pink Floyd fans here, you know, and that's on our anechoic chamber. That's what that big box is up there that behind me. Yeah, you can see it's huge. And a bunch of gear and things like that. But that's really not what I'm going to show you today. What I'm going to show you is out in front of me right now on the bench. So give me a second. I'm going to flip this thing around. Boom. And there we see. So these are some of the things. Like, I missed this yesterday. A lot of you may have seen a lot of places have what's called the Gross 45CA. It's basically a long horizontal tube. It's got slants on each side, a center post, little thing in the middle to hold the top of the headphone. You put it on, you measure it. Great. It measures really well. It's a great piece of gear. The problem is it's a fixed set of dimensions. It's for a nominal head dimension. And of course, as you know, none of our noggins are very much the same. Instead of that, I use the Type 801, this thing, from Crysound. There you go. 801. It's got a pair of 711 couplers. Remember, I covered those yesterday. Those are for the in-ear canal simulator kind of things, right? It's also got, you know, ears on the side, you know, rubber ears on the side. But it also allows you to adjust the height. So I can do for a tall head or a short head as I want. I can also, as you see, I can loosen these things up and I can push it in or out. So right now I got it set for minimum head width. I can set it to the wide head width. I can also change the side. Is your head oval? Is it fat? Whatever needs to be done. So this allows us to do measurements not only at a standard dimension and say, you know, like on our hats and say, how does it work on an average head? But then I can also come over here and say, how would this set of over-ear headphones work on a small head or on a big head or any kind of thing in between, a tall head, a short head. So we have that kind of functionality. It's a much more flexible piece of gear. That's why we use this instead of the 45CA. So we think that this plus our 4100D hats is a much better solution. So that's from yesterday. Today, test equipment. What we've got left here, the last piece, is a Crysound 6151B. You'll find these used in factories throughout the world. A lot in Asia, a lot in America, a lot, you know, in Europe, everything like that. It's a really fast electroacoustic tester. 4 in, 4 out, that kind of a thing. Could test all kinds of stuff. In this case, I'm testing headphones. Obviously, got a cable. I've got red cable goes into the right channel, black cable goes into the left channel, you know, because red is right. That's audio standard kind of thing. So always make sure you're aware of that. And in this case, I'm actually going to measure 2 different headphones. I'm going to measure beryllium and I'm going to measure carbon. And normally we'd have a match set so you see better results. But I just want to kind of show you some really cool thing about the difference between beryllium and carbon and when people hear the difference, what they're hearing about. So this is a piece of test gear. It's got inputs. These go straight to the microphones. They just kind of loop around behind. This is the output, goes to the headphones. USB cable, woohoo, it goes into the computer. And this is what the software looks like. Pretty simple. We got distortion, we got frequency response, we got channel balance, we got impedance, and we have a bunch of other things over here. So in order to run this thing, literally, I just plug my headphones in, and I come up here and I go click. There it actually measured all this stuff at once. So this first one here is distortion. I want to show you guys. So we have a limit set. It's got to be below this. People are like, well, what's that limit at? What SPL? Let me show you guys. There you go. That's running at about 110 dB out of the beryllium, 108 dB out of the carbon. Remember that we had about 2 dB difference on the website in sensitivity? Hey, guess what? That's what it measures. We're not lying. So we're not driving these at the nominal level. We're driving them 10 dB hotter than nominal. Okay, so we're really cranking these things. So this represents, like, I've got the volume really cranked on this stuff. So we see the distortion level. We get a little bit of cavity resonance. So red is right. Remember, red is right. It's same on the graphs here. So that's a beryllium. I mean, that's the carbon because, remember, carbon, beryllium. So red is right. The carbon comes on up, goes around. And you see it's really got no distortion all the way down. I mean, this thing is just neutral flat. It's doing 108 dB SPL plus. Okay, we'll get into the next graph. I'll show you the actual output we're putting. It's 108 dB nominal at 1 kilohertz. That's the distortion. This is the beryllium. And people are like, oh, it's still good. Well, what does that really mean? Here's frequency response. Now, of course, there's differences up here because they're different models, and you hear that difference. You hear that sonic difference. That's why those are different. So we're going to see that also in the channel balance. Down below, though, it's pretty much the same kind of results. So here at 1 kilohertz is where it was measured. It's 108 or 110 dB. See, that's what it's referenced at. There's. At 20 hertz, what are we doing? Crap, we're doing 125 dB at 20 hertz with, well, if you got carbons, less than 0.5% distortion, about 2.5% with berylliums. at 125 dB. You want to know why these things are clean? Because they measure that way. Next, it measures channel balance. So this is taking left minus right, and we see here, you know, it's a little biased towards the left because, you know, the beryllium's more efficient. That's what we actually measured, and here's the difference we see at the high frequencies. Normally you see the line kind of come through to a little bit of wiggly, but it stays within that window that we set there of what passes or fails. And then we look at the impedance. There's the impedance difference between the two units from 20 hertz to 20 kilohertz. Over here in the the rest of it, we've got frequency response, we measure distortion level, we measure impedance level, we measure channel balance, we measure polarities. People are like, why do you wire stuff negative? Well, what we found is that about 65–70% of all portable electronics, including like cell phone outputs and laptop outputs, internally they invert the polarity. So we choose to wire our headphones to be inverted so that 65–70% of the time your headphones will be in phase. Not that absolute phase matters, but some people worry about that, so we freak it out. So anyway, that's the last bits of gear I wanted to show you about. We've got our cool little 801 that we use. That's kind of a 45 CA replacement. We've got our wonderful 6151 test measurement. We actually have a couple of these units. This is just the one that's out right now. We got like 3 of them. And how the software all measures. So there you go. I hope that's educational. So there you go. It's Dan Wiggins again, Periodic Audio. I hope you learned something today. It was fun to make this video. I think we pretty much covered measurement gear and what we do around here. We do some serious stuff. We've got really top-notch tools, and we have some really high-end test tools as well before we ship anything out. So now you know what we look at. You know how we do it. So I'll talk to you all later. Bye.